Hi everyone. So in today's video we're gonna talk about cryptography, and we have this exercise where a friend of mine sent me this message, and obviously you can see this message is not readable, so it has been encrypted, and my friend used the CYPHER encryption to encrypt this message. And now I want to decrypt the message, and what I know is the key that he used to encrypt the message. So my friend used this matrix as the key to encrypt this following message. So for me to decrypt the message, I would have to use the inverse of this matrix, right? So step one, let's find A inverse. And we know the formula for A inverse. I did a video on how to find the inverse of a matrix. You can have a look on that. So we have A inverse is equal to 1 over the determinant of A times the adjoint of A. So if we have a matrix and we want to find the inverse, we take the product between the adjoint and the inverse of the determinant. So let's first find the determinant. So determinant of A would be, if I take my matrix, I would use the last row because we can see that it has a 0 on it. So that would be minus 2 times the determinant of this. If I hide this, so 1 3 minus 1 minus 1, so 1 3 minus 1, then plus 1, which is this one, times the determinant of, I'm gonna hide this one where there is the 1, so I'm gonna have 1 2 minus 1 1, 1 2 minus 1 1. Now I can do this using my calculator, so it would be minus 2 times the product between these two minus the product between these two. So it would be times open bracket minus 1 minus 3, so plus 3 plus plus 3. That would be minus 4, right? Then plus 1 times open bracket 1 minus minus 2, which is plus 2. And we can see that the determinant is minus 1, right? So the determinant is minus 1. Now we need to find the adjoint of A. So adjoint of A would be a big matrix. I'm going to put transpose here. The entries I'm going to put in this are going to be based on the matrix A. So for the first entry, which is this one, I'm going to hide this, and I'm going to put this matrix inside. So I'm going to have 1 minus 1 2 1. I put it here, 1 minus 1 2 1. Then for the second one, for the second entry, I'm going to hide this and this. I'm going to put minus 1 0 1. So minus 1 0 1. For the third one, I'm going to hide this and this. I'm going to put minus 1 1 0 2. Minus 1 1 0 2. Now this is equal to matrix transpose. Then for the first one, I'm gonna have the product of this minus the product of this, which is 1 minus 2, which is 1 plus 2, which is 3, right? Now this is equal to, I'm gonna write the transpose, so this one would become vertical, right? I'm gonna write this row, I'm gonna make it be a column, so 3 1 minus 2, then 4 1 minus 2, then I'm gonna have minus 5 minus 2 3. So basically this is the adjoint of A. Now the formula is this, so A inverse would be 1 over the determinant times the adjoint. So A inverse is equal to 1 over the determinant times the adjoint, which is this matrix. Right. Now this would give me minus 3, minus 4, 5, minus 1, minus 1, 2, 2, 2, minus 3. Right. Now I have the key to decrypt my message. So this is A inverse. So this is gonna be the key to decrypt the message. This message. So in step 2, I'm gonna write my message down, which is D B T D H P I R I V Q R. Let me copy my message down. So this is my message. Step 2, I'm gonna write my message down, and let me also copy this table, these letters, right? So now I'm gonna number my message, so we can see that the D is number 3. So D, I'm gonna put it here. Let me write it in blue. So D is 3. Then I have what? B is 1. Then T is 19. Then D is 3. H, where is H, is 7. P is 15. I is 8. R is 17. I is 8. V is 21. Q is 16. Then R is 17. Now I have numbered the message, and now my matrix, I can see that this matrix, which is the key, is a 3 by 3 matrix. So what I'm gonna do, I'm gonna decrypt them 3 by 3, right? So I'm gonna decrypt first DBT, right? DBT, DBT. How I'm gonna decrypt it is gonna be the product between my key which is the A inverse, which is the matrix to decrypt the message. I'm going to take the product between that and this column matrix where the entries are going to be 3, 1, 19, right? So 3, 1, 19. Let me clear my calculator. So this is going to be the first entry I'm going to have is going to be the product this times this plus this times this plus this times this. And I'm going to take the modular 26 because in the alphabet we have 25 letters, so numbered from 0 to 25, and therefore if I take the modulo 26 I'm going to be within the range. So this is going to be minus 3 times 3, which is minus 9, then minus 4, then plus 5 times 19, and that is 82, right? For the second one, I'm going to have minus 3, then minus 1, then plus 2 times 19, which is 34. For the last entry, I'm going to have 6 plus 2 minus 3 times 19, which is minus 49. Now I'm going to take the mod 26. So 82 modulo 26, I'm going to calculate it by doing 82 divided by 26. Then I'm going to take out the natural part, and I'm going to take the result. I multiply it by 26, and as you can see it gives me 4. So 82 mod 26 is equal to 4. So mod 26. Now 34, let me clear again. 34 mod 26. So it's going to be 34 minus 26 to find the mod. It's going to be 8. And then minus 49 mod 26 is going to be 3. So DBT is going to have this number. Now, second thing I want to decrypt is DHP. DHP is going to be the product between the matrix of decryption, and then I'm going to multiply it by 3, 1, 15. 3, 7, 15. And that would give me minus 9. Then I'm going to have minus 28 plus 5 times 15, which is 38. Then for the second entry, I'm going to have minus 3. Then I'm going to have minus 7. Then I'm going to have plus 2 times 15, which is 20. For the last entry, I'm going to have 6. Plus 14 minus 45, which is minus 25. And that I'm going to take the modulo 26, which is going to be 38 more 26 is going to be 38 minus 26, 12. 20 more 26 is equal to 20. And then minus 25 more 26 is equal to 1. Then I'm going to decrypt IRI. So IRI is going to be the product between this matrix and what? This one. 8, 17, 8. 8, 17, 8. This is 23. Now I have all the numbers I need for the decryption. So what I'm gonna do, I'm gonna write this. I'm gonna write it down horizontally. 4, 8, 3. Then 12, 21. 12, 21. Then 0, 17, 0. 0, 17, 0. Then lastly 10, 23, 23. 10, 23, 23. Now I'm gonna copy this table again. Let me paste it here. So step 3. Now we're gonna decrypt. Let's decrypt the message. Let me paste this table again. So um, let me write it in blue. The number 4. The number 4, I can see it here, is E. Number 8. 8 is I. Number 3 is D. Number 12 is M. Number 20 is U. Number 1 is B. Number 0 is A. Number 17 is R. Then number 0 is A. Then number 10 is K. Number 23 is X. Number 23 is X again. So in conclusion, the message that I received is, so we can see the message he sent me is Eid Mubarak. And so let me summarize. So basically My friend sent me this message and he encrypted the message using CYPHER, and he used the matrix A for the encryption. So for me to decrypt the message, I found the inverse of A, so A inverse using this formula, and A inverse is this, no, it's actually this. And to decrypt the message that I wrote down, so I wrote down the message, I have numbered them based on this numbering, and then I decrypt it three by three, like every three letter. I decrypt them using the product between the decryption matrix and these numbers. So I decrypted first DBT, DHB, IRI, VQR, and then the result modulo 26. I have put them down, I have numbered them, and I realized that the message I have been sent was Eid Mubarak. So I have decrypted the message, and this is the result. Thank you for watching.